Good evening, sir.
Good evening, ma'am. Okay, good evening. The next chapter is general principles of extractions of metals. This general principles of extractions of metals is otherwise called as metallurgy. It's otherwise called as metallurgy. So in the previous scheme of the syllabus, we used to call this chapter as metallurgy. And in CBSE, it's been termed as general principles of extraction of metals. Now, what is metallurgy? How do you define the term metallurgy? This metallurgy is defined as science or technology used to extract a metal economically is called as metallurgy. So metallurgy is a process, it's a science, it's a technology, it's a procedure which is used to extract a metal economically. The chapter clearly says general principles of extractions of metals. Now, metals are found generally in the Earth's crust. Now, we have two types of metals. When we say we have two types of metals, one are reactive, the other one is noble metals. Noble metals, we know gold, silver, platinum, all these are noble metals. And all the other metals, iron, copper, zinc, etc., all these are reactive metals. So these metals are found in the Earth's crust in two states, one in combined state, the other one is in native state. Now, native state is also called as free state. Now, noble metals, which are not reactive, they exist in free state or they exist in native state. So reactive metals, they always exist in the combined state. Reactive metals always exist in the combined state. Now, metallurgy, as we understood the definition, it is a science, it is a technology, it's a procedure used to extract a metal economically. Now, we have metals, two types. One I told you it is reactive metals, the other one is noble metals. Reactive metals always exist in the combined state, and noble metals, they exist in free state. As all the materials found on the Earth are composed of 112 elements known, which constitute the entire matter on the Earth. So in the Earth, there are 120. The Earth is made of 112 elements. Now, recently they've added to 120 elements. In that, some of the elements are artificial, man-made. Therefore, the elements are regarded as the building blocks of the universe. So these elements are regarded as the building block of the universe. These are distributed in all three main parts of the Earth: atmosphere, lithosphere. Among these, lithosphere constitute the main source of the elements. Elements have been broadly divided into metals and non-metals on the basis of their physical and chemical properties. So this we know, elements are basically classified into metals and non-metals. I didn't mention non-metals because we are talking about the extraction of metals. Now, occurrence of the metals. Elements which have low chemical reactivity generally occur in native state or free state or metallic state. Example, gold, platinum. Noble gases is not a metal, but they are also existing in free state. Elements which are chemically reactive, generally they occur in the combined state. So elements which react, they exist in the combined state. Example, halogens, chalcogens. 15th group elements are called as chalcogens, etc. The natural material in which the metal occur in earth is called as minerals. We'll have to learn the 5 terms in order to undergo or learn the chapter extraction of the metals or the principles of extraction of metals. Are you following, Dhanlakshmi?
Yes, sir.
Now, in order to understand the metallurgy chapter, we'll have to understand 5 terms. The first 5 terms is the minerals. The next one is ore. Next one is slag. The other term, what we're supposed to know, is flux, F-L-U-X, flux. The other one is, no, what's that? Gang. The next is gang, okay? Ore, gang particle, or it is called as matrix. And the last term, what you have to understand is slag. So 5 terms. What are the 5 terms? One is minerals. The other one is ore. The next one is gang, G-A-N-G-U-E, gang. The other term is, 4th term is flux. And the 5th is slag. What is this minerals? Now, naturally occurring metallic compounds are called as minerals. Naturally occurring metallic compounds are called as minerals. Now, for an example, if we take iron, iron exists in many forms. One is Fe2O3. This is called as hematite, H-E-A-M-A-T-I-T-E, hematite. The other one is Fe3O4. It is called as magnetite. It's called as magnetite. We have FeCO3. It is called as siderite. See, since iron is reactive, it is existing in the combined form. It exists as oxides, iron oxide. It exists as Fe3O4. It exists as iron carbide. It also exists as iron pyrites, FeS2. It also exists as iron pyrites. Now, all these are called as minerals. All these are called as minerals. What are minerals now? Minerals are naturally occurring metallic compounds. So, metals which exist as compounds in nature are called as minerals. So, for iron, there are 4 minerals. Now, what is an ore? Ore is a mineral from which metal can be extracted economically. Those are called as minerals. Or those are called as ores. Ores are nothing but mineral from which metal can be extracted economically. Now, in case of iron, we have 4 ores, 4 minerals we have learned. That is Fe2O3 hematite, Fe3O4 magnetite, FeCO3 siderite, FeS2 iron pyrites. All these are minerals. Now, we extract iron from hematite. Since we extract iron from hematite, hematite will be called as the ore of iron. Now, what is an ore? Ore is a mineral from which metal can be extracted economically. Now, all ores are minerals, no doubt about it. All ores are minerals. Now, iron, hematite is an ore, and it's also a mineral. But we cannot call all the minerals to be what? Ore. We cannot call. So the second term is, they can ask you for objective type question in part A, part B. So what is the definition of mineral? You should know naturally occurring metallic compounds. What is an ore? Ore is nothing but a mineral from which metal can be extracted economically. The third definition, what we have to understand here is gang particle. What is this gang particle? This gang particle, or it is also called as matrix. Now, this gang particle or matrix is nothing but the earthy impurities. Now, when we say earthy impurities, earthy impurities like sand, clay, dust. All these are called as earthy impurities. So this gangue is otherwise called as matrix. Earthy impurities are called as gangue particles. Sand, clay, all these are examples for gangue particles. Now to remove this gangue particle, we need to use a chemical, and that chemical what we use is called as flux. Flux is a chemical substance which is used to remove gangue particles. This flux is of two types. One is acidic, the other one is basic. Now, acidic flux we will use when the impurity is basic. Now, example for acidic flux, silicon dioxide, sand, SiO2 is an example for acidic flux. Likewise, calcium carbonate or calcium oxide is an example for basic flux. If the impurity is acidic, then we will be using basic flux. Now, what is the slag? Slag is nothing but it's a combination of gangue and flux. Gangue and flux will combine to give slag. So impurities gets eliminated in the form of a slag by the combination with the flux. So these are the 5 terms or terminologies you need to remember so that we can get into the topic of extraction of metals. Now, first 5 terms. First one is minerals. Naturally occurring metallic compounds are called as minerals. There are so many examples here. For galena, PbS, it's a mineral. ZnS, zinc sulfide, it's a mineral. Cinnabar, HGS is a mineral. All these are sulfide ores. We'll come back to that a little later. Now, minerals are naturally occurring metallic compounds. Now, when we talk about an ore is a mineral from which metal can be extracted economically. I gave you an example for iron. So iron contains 4 minerals from which one is used to extract iron. Therefore, iron oxide, Fe2O3, is called as a ore of iron. And next, gangue particle. Gangue particles are nothing but earthy impurities like sand, clay, dust, etc. Now, flux. What is this flux? Flux is a chemical substance used to remove gangue particles. Now, there are 2 types of flux. You should remember acidic flux, SiO2, sand, is an acidic flux. Calcium carbonate or calcium oxide is an example for basic flux. Now, this gangue and flux together gives you slag. Is it clear with these 5 terminologies?
Yes, sir.
Yeah. Now, native ores, when we say native ores, these are combined state. When we say native ores, elements which are very less reactive or not reactive, those exist in free state. Those are called as native ores. Example, silver ore, gold, platinum, mercury, copper. Copper also exists in combined state, but they also exist in free state. That's why we call it as a native ore. Now, sulfurized or arsenical ores. Now, combined state, when we say metals can exist in different combined state. When I say metals can exist in different combined state, just give me a moment. When we say metals can exist in different combined state, now for an example, iron can exist as an oxide. When iron is combined with oxygen, it's called as oxide. If a metal is combined with an oxygen, it is called as oxide ore. Now, if metal, for an example, zinc sulfide, zinc blende, galena, mercury sulfide, all these are combined with sulfur. Therefore, they can exist as sulfide ore. They can exist as what ore? Sulfide, PHIDE. They exist as sulfide ore. Now, if we take NaCl, NaBr, sodium is a metal, and these are halogens. Therefore, they can exist as halide ores. Now, if you take KNO3, metal, potassium is a metal. and they are existing as nitrate. If you take carbonate, FeCO3, so it exists as carbonates. It exists as carbonates. So metals can exist in different forms, in the form of oxides, in the form of sulfides, in the form of halides, in the form of nitrates, or in the form of carbonates. I've just given you a few examples here. Now, sulfurized are arsenical ores. These ores consist of sulfides and arsenides in simple and complex form. Now you see, metal is lead. Name of the ore is galena. It is present in the form of a sulfur, sulfide ore, PbS. Likewise, zinc is a metal. It's called a zinc blend, ZnS. So all these are examples for sulfide ore. See, argentite, silver glance, it is called as. So it is represented Ag2S. Cinnabar, what is the chemical formula of cinnabar? Mercuric sulfide, HgS. Iron pyrites, iron is a metal, it exists as FeS2. So metals can exist as sulfides. Now you can see here, nickel is a metal, copper chalcopyrites, 2. It's very important, CuFeS2. Chalcosites or copper, Cu2S, copper glands. So all these are examples for sulfide ore, and this is an example for arsenide ore. Next is oxidized ore. Oxidized ore. Now, what do you mean by oxidized ore? In these ores, metals are present in the form of their oxides. They are present in the form of oxides or oxysalts, such as carbonates, nitrates, sulfates, phosphates, silicates, etc. Now, hematite is Fe2O3. I told you it's an ore of iron. It's an oxide ore. Magnetite, Fe3O4, it's an oxide ore. Limonite, Fe2O3, 3H2O. It's also an ore of iron. It's also a mineral of iron. Bauxite, Al2O3, 2H2O. So all these come corundum. So it is Al2O3. Diaspore, Al2O3, H2O. Chromite, FeOCr2O3. All these are examples. See, tin stone is called as cassiterite. The chemical formula is SnO2, tin dioxide. So cuprite, ruby copper, Cu2O. Pyrolusite, MnO2. Zincite, ZnO. Rutile, TiO2, titanium dioxide. So all these are examples for metals which exist in the form of oxides. Now the next is carbonate ores. Magnesite, magnesium carbonate. Limestone, calcium carbonate. Dolomite, mixture of calcium carbonate and magnesium carbonate. Calamine is ZnCO3. So the lotion, softness for the skin, the lotion contains calamine lotion. It contains zinc carbonate. It gives smoothness to the skin. Malachite, CuCO3, CuOH twice. Azurite, CuOH twice, Cu2.2CuCO3. Siderite, FeCO3. All these are carbonate ores. Nitrates, chili saltpetre. Sodium nitrate is chemically called as chili saltpetre. Saltpetre is potassium nitrate. All these are nitrate ores. Sulfate ores, Epsom, magnesium sulfate, 7H2O. Barytes, BaSO4, gypsum, calcium sulfate, 2H2O. All these are examples for sulfate ores. And also you can see we have phosphate ores and also we have silicate ores. Right, so many examples are there. So these all are complex, but anyways, remember willemite. Willemite is zinc silicate, ZnSiO4. Mica, potassium oxide, aluminum oxide, silicon dioxide, and water. Fluoroapatite, it is a phosphate ore, calcium phosphate and calcium fluoride. So talc, powder, magnesium silicate and magnesium hydroxide. Asbestos sheets, calcium, magnesium silicate is called as asbestos sheets. So all these are examples for silicate and phosphate ores. And here you can see some of the halides, ores of halides. Metal along with halogen will be called as halide ores. So common salt, sodium chloride. Horn silver, silver chloride is called as horn silver. Carnallite, KCl3 MgCl2 6H2, carnallite. Fluorospar, CaF2, and cryolite, Na3AlF6. It's called as cryolite, Na3AlF6. Next, metals in biology. Metals in biology. Magnesium is found in chlorophyll. Chlorophyll, green color of the leaf, is because of the presence of magnesium. Chlorophyll gives you color, green, and that chlorophyll contains magnesium. Potassium is present in plant roots. Potassium is present in plant roots. Magnesium, iron, and copper are present in chloroplast. Iron is present in hemoglobin, iron Fe2+. Vanadium is present in cucumbers. Zinc is present in eyes of cats and cows. Eyes of cats and cows. I don't know, people eat the eyes of cats and cows. I don't know. And calcium is present in bones. Chromium is present in brown. I don't know what is brown. All right. So these are metals are also present in the biological systems. Now coming to extraction of metals. So a process of extracting a metal is called as metallurgy. The extraction of pure metal from its ore. The extraction of pure metal from its ore is called as metallurgy. In order to extract the metal from ores, several physical and chemical phenomena or methods are used. The method used depending upon chemical properties and nature of the ore. So there are 4 methods of steps involved in the metallurgical process. The first one is crushing and grinding of the ore. Second one is concentration, or it's called as dressing of the ore. Third one is reduction of free metal. And the fourth step is purification or refining. Crushing of the ore or grinding of the ore. Next is concentration. These are the 4 steps involved in the extraction of the metal. Now, crushing and grinding of the ore. Those ores occur in nature as huge lumps. So in the earth crust, metals exist or ores exist in nature as huge lumps, big boulders. They are broken into small pieces with the help of crushers or grinders. These pieces are then reduced to fine powder with the help of ball milling or stamp mill. This process is called as pulverization. Ball milling or stamp mill. Ball milling means if you have seen the cement mixture, like that apparatus, in that a huge ball of iron will be present. They put the ore, small pieces of ore, and they allow it to spin. So what happens? The ball will crush the small pieces into a fine powder. That's called as ball milling or stamp milling, applying pressure, crushing it with pressure so that you get a fine powder. That's called as stamp milling. Both this ball milling and stamp milling is called as pulverization. So first step is crushing and grinding of the ore, crushing the ore to small pieces using a crusher or a grinder, and then subjecting it to ball milling or stamp milling to make it a fine powder. Next is concentration or dressing of the ore. Concentration or dressing of the ore. What is this concentration or dressing of the ore? Now, for an example, if we take 5 kg of gold ore, 5 kg of gold ore. In this 5 kg of gold ore, assume that 50 grams of gold is present. 5 kg of gold ore, we have 50 grams of gold. Now, from this 5 kg of gold ore, you remove the dust particle, you remove the sand particle, you remove stones, majorly you remove, and you reduce this to 500 grams. Assume you reduce this to 500 grams of gold ore. Even in this 500 grams of gold ore, 50 grams of gold is present. How many grams of gold is present? 15. Both the cases 50 grams. So what's the percentage of gold here? 50 divided by 5,000 grams. 5 kg is 5,000 into 100. Here it will be 50 divided by 500 grams into 100. So the percentage will be more here. The percentage of gold will be greater here compared to this. So the term concentration of the ore or dressing of the ore means increasing the percentage of the metal in the ore is called as concentration. So increasing the percentage of the metal is called as concentration. So that increasing the percentage of the metal can be done in different ways. Now, when we say it can be done in the different ways, you should remember for oxide ores, it is physical methods. Physical methods. This is all a physical method. For oxide ore is done by gravity-based separation. Gravity-based separation. So oxide ores are generally concentrated by gravity-based separation, or it is also called as leviation, or it is also called as hydraulic washing. Also called as hydraulic washing. It's an important question. Now, gravity-based separation is generally done for oxide ores. And remember, oxide ores are heaviest form of ores. So oxide ores are heaviest form of ores. Gravity-based separation or leviation. This process of concentration is based on the difference in specific gravity or density, of the ore and gangue particle. Density of the ore and gangue particle. So generally, mud particle, clay particle will be having lesser density compared to the ores, compared to the metals. Now, the sieved ore is either subjected to dry centrifugal separation or is placed in a big shallow tank in which a current of water is blown. Shallow tank in which a current of water is blown. Heavy ore particles settle down at the bottom of the tank, while lighter gangue particles are carried away by the current of water. The process removes most of the soluble and insoluble impurities. For this purpose, Wilfley table and hydraulic classifier are widely used. This method is suitable for heavy oxide and carbonate ores like cassiterite and hematite. So generally it is applicable for oxide ores. Now, if you keep a sloping hearth like this, it is called sloping hearth. S-L-O-P-I-N-G, sloping hearth, H-E-A-R-T-H. Now you keep a finely powdered ore here, and you flush it with water. You pass water. What happens? The water, when you apply pressure, the gangue particles which are lighter will be carried away by, the impurity will be carried away by water. Lighter they will be carried away. What happens now? The heavier metals or the ores which are heavier, they will get accumulated here. So this is called as hydraulic washing, or it is called as gravity-based separation. For this gravity-based separation, they use Wilfley table or hydraulic washing. It is represented like this. You can see crushed ore is placed and water is passed. And this Wilfley table, there will be agitation, there will be mixing. They'll keep on shaking it. So what happened? Lighter particle will be carried out by water and get drained here, and ores will be settling at the bottom of the pores like this. So this is called as gravity-based separation, and gravity-based separation is done for oxide ores. Did you follow this?
Yes, sir.
Next, what we have is froth flotation. This froth flotation is a process of concentrating sulfide ores. Sulfide ores are concentrated by froth flotation. Generally, sulfide ores. Now, in the case of gravity-based separation, this is based on specific gravity. or it is called as, it's based on density. The principle is based on density. But here, in case of froth flotation, the principle involved in concentration is based on a property called as wetting property. Now, I told you the froth flotation is generally applicable for sulfide ores. Now, I told you the principle here is wetting property. Now, the sulfide ores are not wetted by water. They are wetted by an oil called as pine oil. But the gangue particles or the impurities, mud particle, clay particle, they will be wetted by water. You know that, at least when rains, you know that water, what happens to the mud or the clay? It becomes like a paste, it gets wet. So this is the principle involved in concentrating sulfide ores. And the name of that process is called as froth flotation. In some cases, for example, sulfide ores of copper, zinc, and lead, concentration is brought by this method. Is taken of preferential wetting of the ore by oil. I told you the sulfide ores will be getting wetted by oil. Finely ground ore and finely ground ore will finely ground ore is taken in the tank. See, this is finely powdered ore is taken in the tank containing water. 1% of pine oil or turpentine oil is added. So this tank contains a finely powdered ore. Along with this, we have a pine oil or turpentine oil. A strong current of air is blown. You can see air is blown through this. Air is blown through the suspension. Produces heavy froth or foam on the surface. It produces heavy froth or foam on the surfaces. Why? Because the metal sulfide is wetted by oil. So into oil, if you pass air, what happens? There will be foam. So metal sulfides, sulfide ores are wetted by oil and they raise to the top and come out. But the gangue, which is not wetted by the oil, which is wetted by water, they settle at the bottom. They settle at the bottom. Here the gangue particles will settle at the bottom. So gangue particle can be removed. This process is called as froth flotation. So separation of or concentration of the sulfide ores based on the wetting property is called as froth flotation. Did you follow this froth flotation?
Yes, sir.
What happened here? All right. So in froth flotation, we use activators and depressant, all that. And you can see here, for instance, galena is used usually associated with sphalerite, zinc sulfide, and pyrites, iron pyrites, iron sulfide. Concentration of galena is carried out with passing potassium ethyl xanthate as a collector, along with sodium cyanamide, an alkali. It's a depressant. Where what happens? This depressant, we want iron sulfide. We don't want zinc sulfide and iron sulfide. We want lead sulfide. Sorry, we want lead sulfide. We don't want zinc sulfide and iron sulfide. But these two are present along with what? Lead sulfide. So that what they do is they add collector like potassium ethyl xanthate and sodium cyanamide and an alkali as a depressant. So whereby the flotation property of zinc sulfide and lead sulfide is depressed. So that means zinc sulfide and iron sulfide will not come to the surface. It will be depressed because of the sodium cyanamide and potassium ethyl xanthate. Mainly, lead sulfide passes into the froth when air of current is passed. Air current is flown in, which is collected. After lead sulfide is removed from the froth, some copper sulfate is added as an activator, and air is blown. The flotation property of zinc sulfide is increased which is now removed. All right. So this is how, in case of froth flotation, we'll use a collector as well as a depressant. That is for an example. Now, this picture should have been given for the third method of concentration, that is called as magnetic separator. Magnetic separation. So this magnetic separation is performed, either the ore should be magnetic or the gangue should be magnetic. Any one can be magnetic. Then we can concentrate the ore by called as magnetic based separation. Now you can observe this very clearly. There is a belt, and there is, if you have gone to a floor mill, you would have seen two wheels. Along with that, there's a belt. Here also same concept. But here, this wheel is non-magnetic and this wheel is magnetic. This wheel is magnetic and this is non-magnetic. Now, powdered ore you put and you switch on the current. What happens? The belt carries the ore. So when the ore is put, magnetic ores will fall very close to the magnet. You can see the magnetic ore fall very close. The impurities will fall away. They've shown it very close here. The impurities will fall away from the ore. So what happens now? When the impurities are removed, most of the time, most of the impurities are removed, this concentrated ore will contain metal with higher percentage. This process is called as magnetic based separation. Now, any one can be magnetic here. Electromagnetic separation. The mineral and not gangue is attracted by the magnet. If the mineral and not gangue is attracted, it can be concentrated by magnetic based separation. Chromite ore, FeCrO4, being magnetic, can be separated from non-magnetic silicons. Silicons is sand by this method. Sometimes two minerals occur together in which one happens to be magnetic, the other magnetic. By magnetic separation method, non-magnetic materials is separated. For example, tin stone or cassiterite is SnO2. It is non-magnetic. It contains wolframite, FeWO4, as a magnetic. So this is non-magnetic. It's iron. Wolframite is magnetic. This is tin oxide, non-magnetic. Iron, wolframite is the ore of iron. Actually, wolframite is the ore of tungsten, which is magnetic. They are separated by this method. Now, what happens if you take tin stone, which is non-magnetic, falls away from this, and wolframite will fall close to the magnet. So we can separate two metals also based on magnetic based separation. At least one should be magnetic. The last method of concentration is chemical method. So these three methods, what we learned is physical methods: gravity-based separation, froth flotation, and magnetic-based separation. These three are physical methods because there is no chemical reaction taking place. There's no chemical reaction taking place. Now, we have the chemical method. The second one is chemical method. Now, this chemical method is, first one is calcination, the other one is roasting. Now, calcination and roasting we will learn later. In chemical methods, we have a process called as leaching. This is a chemical method. This is important, leaching. Now, in case of leaching, it involves the treatment of ore with suitable reagent as to make it soluble while impurities remain insoluble. So, in case of leaching, the ore is treated with a suitable reagent to make it soluble while the impurities are insoluble. Now, for an example, ore of aluminum is bauxite. If you have to concentrate bauxite, this bauxite is first allowed to react with sodium hydroxide. Bauxite is allowed to first react with sodium hydroxide. Now, when bauxite is allowed to sodium hydroxide, we get sodium aluminate, 2NaAlO2. Because aluminum oxide is soluble in sodium hydroxide. All the impurities will not be soluble in sodium hydroxide. That can be removed by filtration. The impurities remain unaffected and separated as insoluble red mud is filtered off. The filtrate is diluted and some freshly prepared aluminum hydroxide is added. Now the filtrate contains what? Sodium aluminate. To this, we add freshly prepared aluminum hydroxide. When we add freshly prepared aluminum hydroxide, this acts as a seeding agent. It acts as a seeding agent. A seed can become a tree. It can give many fruits, many seeds. So when you add little of aluminum hydroxide, all the sodium aluminate will be converted to aluminum hydroxide. So little of aluminum hydroxide we have to add, that's act as a seeding agent. So all the sodium aluminate will get converted to aluminum hydroxide. This aluminum hydroxide is calcined, heated. Now this aluminum hydroxide, when you heat, you will get Al2O3 plus 3H2. This is free from impurity, Al2O3. This method is called as leaching. So this method is called as leaching. Did you follow these three reactions? This question is an important question for your board exam. All the four what we learned: gravity-based separation, froth flotation, magnetic-based separation, and leaching. All the four is important. Now coming to the next two questions. What is this roasting and calcination? Now roasting and calcination. Now generally they can ask you for 2 months. What is calcination? First we'll learn roasting and then we'll go for calcination. What is this roasting? Heating the concentrated ore. Heating the concentrated ore in the presence of air or oxygen is called as roasting. So roasting is heating the concentrated ore in the presence of air or oxygen. So this roasting is generally applicable for sulfide ores. So roasting is generally applicable for sulfide ores. Now for an example, if you take zinc sulfide, if I heat it with oxygen, so it gets converted to zinc oxide, giving you sulfur dioxide gas. So roasting and calcination is done for various purposes. I will tell you later. Now roasting is nothing but heating the concentrated ore in the presence of air or oxygen is called as roasting. Now example I've given you. So if they ask you what is roasting for 2 marks, you should explain with an example like what has been written. Now calcination. Calcination is heating the concentrated ore in the absence or minimum supply of air or oxygen. So calcination is heating the concentrated ore in the absence of air or minimum supply of oxygen or air is called as calcination. Now here you can see zinc carbonate. This is applicable. Calcination is generally applicable for carbonate ores. So zinc carbonate, when you heat, it will decompose to give zinc oxide, liberating carbon dioxide gas. So calcium carbonate, when you heat, it will decompose to give calcium oxide, giving you carbon dioxide. So roasting is heating the concentrated ore in the presence of air. So when you heat, it's applicable for sulfide ores. You can see sulfide ore is converted to oxide here. Zinc oxide is converted to zinc sulfide is converted to zinc oxide. Now calcination is heating the concentrated ore in the absence of air or oxygen. So zinc carbonate gets converted to zinc oxide. Likewise, calcium carbonate gets converted to calcium oxide. I hope you followed roasting and calcination.
Yes, sir.
Yeah. Now coming to the next concepts. So much is there here, not necessary. Oh. Can you see the screen?
Yes, sir.
Now, we have few terms to be again remembered. The reduction of metal. reduction to free metal. The third step in metallurgy. The first one is pulverization. Second one is concentration. And the third one, what we are learning, is called as reduction to metal. Some of the methods commonly used to get free metal from concentrated ore are given below. Reduction. The first one is smelting. First one is smelting. S-M-E-L-T-I-N-G. It is similar to melting. Right? The process of extracting a metal in the state of fusion is called as smelting. In this process, the ore is mixed with carbon, obtained after the above reaction, and heated in a suitable furnace. Along with a suitable flux is added during the operation to convert the non-fusible gangue to a fusible slag. Now, reduction, for an example, if zinc oxide is heated with carbon. Now, carbon is a very well-known reducing agent. Now, what happens? Carbon and oxygen gets eliminated as carbon monoxide. What else is given? You get zinc. So, removal of oxygen is called as reduction. From zinc oxide, oxygen is removed. Therefore, this process is called as reduction. But now, similarly, if you take iron ore, it is hematite, Fe2O3. Now, in order to reduce hematite, we require carbon monoxide. We require carbon monoxide. The reducing agent is carbon monoxide. We will learn about it in detail. Now, carbon monoxide reacts with oxygen and gets eliminated as carbon dioxide gas, and we get iron. This is also reduction. But in case of extraction of iron, the impurity is sand. This is gangue particle. To remove the sand, we need to have a flux. The flux is basic calcium oxide, gives you calcium silicate. This is called as slag. Calcium silicate is slag. So this process is called as smelting. So you can see here clearly smelting. The process of extracting a metal in the state of fusion is called as smelting. In this process, ore is mixed with carbon. Here the carbon monoxide is the reducing agent, obtained after the above reaction and heated in a suitable furnace, blast furnace. A suitable flux is added. Here the suitable flux, calcium carbonate is added, and it will decompose into calcium oxide. We will learn the reactions in detail later. Suitable flux is added during the operation to convert the gangue to the slag. The gangue particle is converted to the slag. This process is called as smelting. Without the flux, if you prepare a metal, if you extract a metal, it is just called as a reduction. It's just called as reduction. The second method we have is called as aluminum thermite process. Aluminothermite process, or it's called as reduction using aluminum. So whenever we use aluminum as a reducing agent, it will be called as Goldsmith aluminothermite process. Now, the carbon cannot be used as a reducing agent for all. Even though it is cheaply available and it is more, carbon cannot be used. Therefore, when we use aluminum, now chromium oxide, we need to extract chromium. You cannot use carbon as a reducing agent. So therefore, they're using aluminum. So what happened? Aluminum has more affinity towards oxygen. You will get Al2O3 and you get chromium metal. So similarly, manganese we want. We cannot use carbon. We use carbon, you get manganese carbide. So we use aluminum. So what happens? Aluminum and oxygen gets eliminated as Al2O3 and you get manganese. The reaction is not balanced here. Don't worry. So whenever we use aluminum as a reducing agent, then we call that process as Goldsmith aluminothermite process. It's otherwise called as reduction by aluminum. Next is self-reduction. The process is also called as auto-reduction process or air reduction process. The sulfide ores of less electropositive metals like mercury, lead, copper, etc. are heated in air as to convert a part of it to its oxide or sulfate, which then reacts with remaining sulfide to give the metal. So extraction of copper we have in copper, we have copper matte. I don't know whether you learned it in college, copper matte and reduction process. We will learn about it in detail. That's called a self-reduction process. The next we have is electrolytic reduction process. Electrolytic reduction process, extraction of aluminum. So that also we will learn later in the syllabus. And next we have a refining process, purification, the precipitation or displacement method, purification of refining metals, purification of refining. So we have a precipitation method or displacement method, hydrometallurgy also. We have pyrometallurgy. What we learned here is called as pyrometallurgy. Pyro stands for high temperature. Pyrometallurgy. All this, still three self-reduction. And this is electrometallurgy because we're extracting the metal using current. Therefore, it's called as electrometallurgy. More electropositive metals will be extracted by electrometallurgy. Less electropositive metals will be extracted by pyrometallurgy. Noble metals are extracted by displacement method, otherwise called as hydrometallurgy. Now, this method is used for the extraction of metals such as cadmium, copper, gold, and silver. It's generally for gold and silver, or noble metals. A metal having higher electrode potential, less reactive, is added into a solution of metal with lower electrode potential, more reactive metal, which result in the displacement or precipitation. Now, for an example, gold ore is dissolved in potassium cyanide. When gold ore is dissolved in potassium cyanide, we get a complex like this. Okay, this is silver or gold, anything, gold or silver. All right, AgCN. When this is allowed to react with a solution of zinc, zinc being more reactive will displace silver. And zinc being more reactive will displace gold here. So you get silver and gold. This process is called as hydrometallurgy. We will learn the extraction of hydrometallurgy also in detail in the next class. Ma'am, I'll stop the class, ma'am. Ma'am? Bye then.